Welcome back, everyone. In this video, we will talk about level curves and contour maps. Let me give you the definition of what a level curve is, and then we will do some examples. So level curves of a function f of two variables are the curves with the equation f of x comma y is equals to k, where k is a constant in the range of f. So pretty much you have a surface in 3-dimension, and you're slicing it up at a different values of k and looking at that picture in 2-dimensional space. So so level curve is a curve in xy plane that shows where the graph of f has a height k. So we will look at that for two examples in this video. And then at the end, when you have all of those collections of level curves, we'll call that as a contour map. So that is our definition. Let's take a look at our very first example. So here we have this function right here. This is a function of two variables. So you have some surface, and we're just going to let f of x comma y be some constant k. So we know that is your z value. So instead of writing a z, we're just going to call it, let that be some k. And now we look at different k values to have the graph in 2-dimensional space. So I have my 2-dimensional space right here. Here's our xy plane. This is the x, this is the y. So let's start with something simple. Let's say k is equal to 0. If k is equal to 0, I set this equal to 0. So I have 0 is equal to 1 minus x plus x squared, y squared, I'm sorry. And then by rewriting the equation so I know how to graph this, this is x is equal to 1 plus y squared. So we know it's a parabola facing along the x-axis, positive x-axis with the x-intercept 1. So here is the intercept, and you just draw the parabola facing this way. So that's your level curve at the value k equals 0. And then you just create a couple more, and just to have an idea how the contour map is generated. So the next convenient value I'm going to choose is k equals 1. If I let k to be 1, then my equation becomes the following. Again, I'm replacing 1 here. So you'll have 1 is equal to 1 minus x plus y squared. Again, you have an equation in 2-dimension, and the 1 will cancel out. If you rewrite the equation, you simply have x is equal to y squared. So again, another parabola along the x-axis, and the intercept, x and y intercept, are going to be 0, 0. So that's just going to be right here. I'll just put that in a different color. So this is the next parabola. And this is the level at k equals 1. So hopefully you have an idea of how this is generated. The next value I'm going to pick is k equals 2. So if you like k equals to 2, you're going to get the following equation. So you'll have 2 is equal to, again, I'm substituting 2 for f of x comma y. 2 is equal to 1 minus x plus y squared. Again, I can subtract 1 from both sides and then add x to both sides. You will have x plus 1 is equal to y squared. Another parabola. And now for this one, the x-intercept, it's going to be at -1. So I will have graph right here passing through that. And of course, you can find more intercept, but I will just label that because we already know how the general shape looks. So it's just a parabola like this. So this is for k equals 2 and so on. And then if you like k equals 3, you're going to have another one right here. And I hope you got the idea. So it's just a lot of parabolas in this direction. You can also do the same thing by setting k to be negative values, say -1. Then you will create a parabola probably like that and so on. So this is our contour map. So this graph right here is what we call contour map, just collections of a lot of level curves. Let's take a look at another example. So for this problem, we're going to be sketching the contour map for this function. Again, this is a surface in 3 dimensions, so the level curves are going to be in 2 dimensions by letting this z to be some constant k. So again, I will start off with by letting my function f of x comma y be some constant k, and I choose some values for k. So if I start off with k equals 0, then I have my equation 0 is equal to x squared minus y squared. This is, again, two-dimensional curve. So if you try to reformulate this, you'll have x squared is equal to y squared. And then if I take the square root on both sides, I have x is equal to plus or minus y, or y is equal to plus or minus x. Well, I know this is just a line passing through the origin in the xy plane, so that's what we're going to draw. So when k is equal to 0, we actually just have a line passing through, in fact, two lines, one going this way and another one going this way. So that's the one with negative slope. So this is our graph. They're passing through the origin. So both of these represents the level curves when k is equal to 0. Now let's take a look at another level. So for instance, I can pick again k to be convenient value 1. If k is 1, I'm setting f of x comma y to 1. So I have 1 is equal to x squared minus y squared. You should note that this is a hyperbola. Hyperbola along the x-axis, because x is positive. So the x squared term is positive. So you would draw something like this and roughly sketch. So do your best to sketch this curve as closely as possible. So I'm just going to retrace this one. That is the hyperbola of the equation x squared minus y squared is equal to 1. This is our level when k is equal to 1. Okay. All right, let's do one more so that you can understand where this is going. If I let k equals 2, I have another family of hyperbola. If k is equal to 2, you'll have 2 is equal to x squared minus y squared, another hyperbola of the same style. So you can think of like that. So you just have family of hyperbolas as k is bigger than 0. So this will be k equals to 2 and so on. So I hope you get the idea on how this direction is approaching. Now, if I like k to be a negative value, let's say if k is a value less than 0, say negative 1. So if k is negative 1, you have, so plugging in negative 1 right here, I have negative 1 is equal to x squared minus y squared. Multiply both sides by a negative 1. You have 1 is equal to y squared minus x squared. So now x squared is negative, which means the hyperbolas, this is also hyperbola, as you should notice. Our hyperbolas are now along the y-axis since the y term is positive. So I'll have one curve like this, another one like this. So again, do your very best to sketch them as nicely as possible. So this is our level for k equals negative 1. And if you substitute more negative values for k, you'll have family of hyperbolas in the same direction. So probably something like this. This will be another, maybe k equals negative 2.